I'm going to discuss sums and differences of rational expressions with regards to equal denominators. I'm going to do several examples. Suppose we wanted to add 3 over x minus 2 and 5 over x minus 2. So we're going to use the same procedure we would use if we were dealing with numerical fractions. So that means because the denominators are both the same, the answer is going to have the same denominator. And the numerator of the answer is going to be the sum of the numerators of the two original rational expressions. And so we get 8 over x minus 2. Okay, now let's do a difference of rational expressions, shall we? So 5y over 3y plus 5 minus 9y over 3y plus 5. As before, we're going to use the same procedure that we would use if we were dealing with numerical fractions. So the denominators are both the same, so I'm going to make the answer have the same denominator. And now I'm going to subtract the numerators, and that will give me minus 4y. So that is the answer. All right, now I would like you to do an example. All right. Would you please do this? Would you calculate this sum? 2x minus 1 over x squared plus 5x plus 6, that rational expression, plus 4 minus x over x squared plus 5x plus 6. Pause the video now and calculate this sum, please. All right, I will go ahead and do it now, show you what I would get. So the denominator is going to stay the same. And adding the numerators, I'm going to have 1x left over, and minus 1 plus 4 is going to give 3. So that is that is correct the way it stands. Now, bonus points if you try to simplify your answer. Remember that the way to notice if it's possible to simplify is to factor. If I factor the bottom, I get x plus 2, that binomial times x plus 3. So then I see that I have the same binomial on top and bottom, so I can discard those. And the final simplified answer is 1 over x plus 2. Let me try to do it in red. 1 over x plus 2. All right. Let's have you do a difference now. Calculate a difference. So would you please do 2x over 3 minus 5 over 3. Okay, so pause the video again to take care of this one. And so I hope you got 2x minus 5 all over 3. Now, what if I would have asked the question this way? What if I would have asked you to do 2x over 3 plus 5 over minus 3? Now, I think you would agree that the denominators are not the same for both for both pieces. All right, the second piece only has numbers, so I guess we should call it a fraction. However, we know that we can easily replace the second term with a version that has a 3 in the denominator. And so then we can go ahead and do this procedure and get the same answer. All right? So that notion, we're going to talk more about that later. The idea of changing a fraction, changing the denominator, changing the numerator to be what we want. All right? Let's do another example where the denominators are not the same, but there is a little replacement you can do. All right, so I'll let you try one of those now. So how about this one? 2x plus 1 over x minus 5 minus x minus 4 over 5 minus x. Pause the video and see if you can do that difference. All right, so I'll go ahead and do it. So the thing to notice here is that even though the second rational expression does not have the same denominator, we can swap the order of the pieces in the second denominator as long as we do one thing. We have to multiply by minus 1, either the numerator or denominator of the second rational expression, or just change the minus to a plus, change it from a difference to a sum. All right, and so doing that, now we can find the answer, and it is 3x minus 3. Okay. Now, you could factor the numerator, and in this case, factoring it is not going to allow you to simplify the answer any farther, so that's as simple as we could make it.